Alright, you guys, this is part one of the ACP Semester 2 review. So starting off with number one, which graph represents the curve given by the parametric equations x equals negative 2t squared plus 1, y equals 2t minus 3 over the interval negative 2 to positive 2. So thankfully they told you exactly what type of problem it is. They said that it is a parametric equation and they give you the equations for x and y, and they also give you the parameter interval, which is from negative 2 to positive 2. So if you remember from class, the parametric equations have a 3-column table where you have variables t, x, and y. Now, the t column is represented by all the values in the parameter interval. So you're going to go between negative 2 to positive 2, increasing by increments of 1. So that's from negative 2 to positive 2. We could do x and y by hand by plugging them into the equations, but that takes a long time. And thankfully we can do it in the calculator. So what you're going to do in your calculator is first open up a graph. When you're in the graph, you're going to go to menu, then graph entry, and then parametric. Then there you're going to have the x and the y, where you can type the corresponding equations from the question. So that's negative 2t squared plus 1. And you're going to make sure you use t. Don't use x because the variable is t. And then 2t minus 3. Now, for the parameter interval, the default is 0 to 6.28, but you're going to want to delete that and do it from negative 2 to positive 2, and then you're going to press enter. You're going to get a graph that looks like this. Notice that they almost all look identical to the answer choices, so they all make this like sideways parabola. There are a few differences though. It'll help if we're able to fill out this table. So on your calculator, you're going to go to menu, and then you're going to go to table, and then split screen table, or you can do Control T, and then that will also give you the table. So you're going to scroll up until you see that t is negative 2, and then you can write down those coordinate points for the x and the y column. So notice that right next to t we have the x column, and then here we have the y. So I'm going to write them here on our notes, just going all the way down. Negative 7, negative 1, negative 5, positive 1, negative 3, negative 1, and negative 7, positive 1. Now that we have those values, we're going to be able to go back to the graphs and make sure that things are where they are supposed to be. So notice that they, like I said earlier, they look almost the same. Here we have positive 2, positive 2, but on C and D, positive 2 and positive 2 are at the bottom. Now, if we look at our positive 2, it has to be at negative 7, positive 1. So if I were to graph negative 7, positive 1, negative 7, positive 1 on all of these, it has to be, so they all have a point there, but negative 7, positive 1 is for positive 2. So these that have negative 2, that is the incorrect point for t equals negative 2. So C and D are no longer options. So now we got to pick between A and B. The other difference is that these arrows are pointing down while these arrows are pointing up. Now that parameter interval tells you where you're starting and where you're stopping, and the order, the direction. So if you're starting at negative 2, so you're going to analyze these two. So these arrows are going down towards negative 2, meaning they stop at negative 2. So that's backwards because you're starting at negative 2. So notice this one starts at negative 2 and is going in the direction of positive 2. So here B would be the correct answer. Moving on to number 2. An ellipse centered at the origin has a vertical major axis of 12 units and an eccentricity of 0.5. What is the equation of the ellipse? Now, in class, I didn't specifically teach eccentricity, But if you look at your formula chart on the back page where the conic sections is, you will see that the equation for eccentricity is right here. And it's a very simple equation. So E equals C over A. So I'm going to go back to the problem and I'm going to write that down right under eccentricity. So E equals C over A. And they said that the eccentricity is 0.5. And that's equal to C over A. So I'll come back to that in a second. Let's see what else they told us. An ellipse centered at the origin. Okay, so if it's centered at the origin, that means the center is 0, 0. And remember that the center is represented by H and K. It also says that it's vertical, so that's good to know because remember you can either have vertical or horizontal ellipses. And then it says that the major axis is 12 units. So remember the major axis is equal to 2A. So the semi-major, which is just equal to A, would have to be half of the major, which is 12. So the semi-major would be 6 units. Okay, now that we know that A is 6, we can plug that A into the eccentricity and we're going to be able to get C by itself. So that would be 0.5 is equal to C over 6, in which case you would multiply both sides by 6 so that these can cancel out. And then 6 by 1/2 is 3. Now that we know A and C, we can use the ABC relationships for ellipses, which is C squared equals A squared minus B squared. And we'll plug everything in. So that's 3 squared equals 6 squared minus B squared. That's 9 equals 36 minus B squared. Subtract 36. And 9 minus 36 gives you negative 27. That's equal to negative B squared. Notice that they're both negative, so you can just drop the negative. And then so the square root of 27 is not a perfect square, so B will just have to be the square root of 27. Okay. Now, for whenever you're writing these equations, all you need is H, K, A, and B. So thankfully we have all of those. Now we're going to go look at the formula chart, and it has to be for a vertical ellipse. Now, how do you remember on the formula chart which is vertical and which is horizontal? Well, when you're looking at ellipses or hyperbolas, if you look at the standard form, the very first equation for both starts with x minus h. That h can be a trigger for you to remember horizontal, meaning that all of these here are for the horizontal side. And by default, the second ones have to be for vertical. Okay, and notice that the vertical ones on neither of them start with H, they start with K. Okay, so if it starts with the letter H, it's for horizontal. This ellipse was vertical, so we're going to be following this standard form, y minus k squared. So y minus k squared over a squared plus x minus h squared over b squared equals 1. Okay, y minus k, that's y minus 0 squared. A squared is 6. X minus h, where h is 0. And b is the square root of 27 squared. Okay, notice that so this is unsimplified, but notice that all the answer choices start with x. So we're going to move this x to be at the front, and we're going to put the y second. So x minus 0 is just x. So it would just be x squared, and here the square root of 27 and the square cancel out, leaving you just 27. Y minus 0 is just y. 6 squared is 36. So this would be the final answer, and the answer choice that matches is D as in dog. Okay, let's go to the next question, which is conic sections. If a plane intersects a double napped cone parallel to the slant height of the cone, what type of conic section is formed? So the conic sections, remember, look like two ice cream cones facing each other. So it'll look something like this. That is not going to be great, but I'm going to try my best. And let me copy and paste this a few times. Okay. So depending on how you intersect into the then the double knot cones is going to determine the section, the shape that's formed on the inside. Okay, so you can either be parallel. So let's say I cut it parallel to the base height. Okay, so the base height is this, and I cut it parallel. If I cut it exactly parallel on the inside, you're going to get a perfect circle. If you're looking at it from the top down, because remember the bases of these are circles. They look like ellipses right now. They look like ovals because of the way I shaped it, but they're perfect circles. So if it's parallel to the base, it is a circle. If instead of it being parallel, it is perpendicular to the base, and perpendicular means that it's like intersecting perfectly at a 90-degree angle, then on the inside you see you're gonna have two little parabola shapes like this, and when you have two parabolas shaping each other, you get a hyperbola. So if the plane intersects perpendicular to the base, you get a hyperbola. If it intersects at parallel to the slant height. Now the slant height could be this slanted line or it could be this one. Okay, so let's say I cut it parallel to the slant height, but it goes all the way through to the base. You see how it goes through the base? So if it goes all the way through, you're going to be stuck with a parabola shape. If it's neither parallel nor perpendicular to the base or the slant height, and it's just like a random line going through the cone like this or something, then the shape that you're going to see on the inside is more of an oval shape. So that one creates an ellipse. Okay, so just to recap, if it's parallel to the base, it's a circle. Perpendicular to the base, hyperbola. Parallel to the slant height, parabola. And then neither parallel or perpendicular, just a random line, you're going to get an ellipse. Okay? So this question in particular, it says parallel to the slant height. We now have discovered that if it's parallel to the slant height, it's going to be a parabola shape. So this is A as in apple. Okay. If you have a hard time remembering this, I would probably suggest watching that 5-minute YouTube video I uploaded the other day, just to refresh your memory, and then just quiz yourself until you can remember which shapes are formed. Moving on to number 4. What is the rectangular form for the curve given by the parametric equations x equals t squared plus 5t minus 1, y equals t plus 1? Okay, so they tell you it is a type of parametric equation, so that's good. I'm going to rewrite these equations really quick. X equals t squared plus 5t minus 1, y equals t plus 1. Okay, notice, however, that none of these answer choices have the variable t, but we have t in our x and y. So we got to figure out a way to get rid of t. And in order to do that is basically solve for t. You want t by itself, so then you can have it in terms of either x and y. Now the easiest formula here to solve for t would be the y equation. So if you subtract 1 on both sides, then you get y minus 1 equals t. So notice that now we have t by itself, and we're able to put that t into these t's over here. Let me move this over, and I'm going to highlight this in green, and we're going to put those in these t's right here. So x equals y minus 1, and make sure you put it in parentheses. Now we have y minus 1 squared. That is going to be y minus 1 times y minus 1. Anytime something is squared, you're multiplying it by itself. And so you end up with two binomials that you need to multiply. And the easiest way to do that is FOIL or the box method. I prefer the box method. You can do FOIL if you want. And you got y minus 1 times itself. Okay, so y times y is y squared. Negative 1 times y is negative y. And negative 1 times negative 1 is positive 1. Notice that the like terms are negative y and negative y. So I'm going to come back here. X equals y squared. Negative y plus negative y is negative 2y. Then you got the plus 1. This 5 needs to be distributed. So 5 times y is 5y. 5 times negative 1 is negative 5. Then you got the minus 1. At this point, you need to combine like terms. I have a y squared, but there's no other y squareds. I have negative 2y, positive 5y. And then the other option are the numbers positive 1, negative 5, negative 1. Okay, so I'm going to combine my like terms. There's no other y squared, so that's coming down. Negative 2y plus 5y is positive 3y. And positive 1, negative 1 cancel, leaving you just negative 5. And the correct answer choice would be D as in dog. Okay, so again, just solve for t, either x using x or y, and then plug t into the other equation you haven't used yet. Number 5, a ship leaves port and travels on a constant course and at a constant speed for 15 days to reach its destination. If the ship's port is represented by the vector 0, 0, and its destination is represented by the vector negative 8, 25, negative 30, which vector represents the ship's position at the end of the third day? So let's highlight some important information. So constant course, constant speed, 15 days, the starting vector, the ending vector, and then they want to know at the end of the third day. So I can plot this. So the port is going to be at the origin at 0, 0, and the ending location is negative 825, negative 30. And it says that it's going at a constant course, meaning there's not going to be any, left or right or anything, and a constant speed. So if it's a constant speed, constant course, that just means you're going straight there. So it's going to be literally a straight line. And it's going for 15 days. So what you can do is figure out how far they travel every single day by dividing the vector by 15, and then you can multiply it by 3 to figure out the distance after the third day. So if we have a vector, the final vector negative 825, negative 30, and you divide those numbers by 15, then you figure out how much they travel every single day. That vector is negative 55 and negative 2. But that's every single day, and we want at the end of the third day. So then you have to multiply that number by 3, and you distribute that number into everything in the vector. And 3 times negative 55 is negative 165. 3 times negative 2 is negative 6. So the final answer would be B as in boy. All right, moving on to number 6. What are the polar coordinates of the point 2, negative 2? So polar coordinates are written in terms of r and theta. This one has to be rectangular, which is x and y. So the way to find r is a modified version of the Pythagorean theorem, which is instead of a squared plus b squared equals c squared, you're using r squared equals x squared plus y squared. Excuse me. So r squared equals 2 squared, and that negative 2, make sure you put it in parentheses, okay? So 2 squared is 4. Negative 2 squared is also 4. 4 plus 4 is 8. So when you take the square root, r is equal to the square root of 8. Notice that none of the answer choices have the square root of 8 in their radius, meaning they simplified it. So you got to figure out two numbers that multiply to 8, where at least one of those numbers is a perfect square. Those two numbers would be the square root of 4 and the square root of 2. Okay, so 4 times 2 are still 8, and the square root of 4 is a perfect square, which equals 2. And so you get that r is equal to 2 square root of 2, so you can cancel out a and b. So even if you get this far, at least you get a 50-50 chance of guessing the correct answer. Another way you can better, like let's say you forget the equation for the angle, look at the coordinate point they gave you and figure out what quadrant that's in. So when you have a positive x, negative y, that has to be in quadrant 4. Okay, you got a positive x, negative y. And then you can analyze the angles they give you and figure out which quadrants they are in. Now for this method, you do have to know your unit circle. So if you don't know your unit circle, then this is not going to work, and you should remember the equation for the angle. But if you do remember, this would be in quadrant 4, and this would be in quadrant 2. Okay, so remember, we do your little unit circle. This would be 4 pi over 4, 8 pi over 4. So 7 pi is here in quadrant 4, where 3 pi over 4 would be in quadrant 2. Okay, I'm still going to show you how to find it by hand. So the equation for the angle is x equals r cosine theta. This equation, you should probably make your best effort to remember it, because it is in both polar to rectangular and also rectangular to polar. So on some of them, you use it to find x. On some of them, you use it to find theta. We know x is 2. We know the radius is 2 square root of 2. And then at this point, you would divide by 2 square root of 2 on both sides. These would cancel out, and then you would go ahead and take the inverse on both sides and get theta. Okay, so let's go to the calculator. So we have where are the numbers? The inverse cosine of 2 over 2 square root of 2, and press enter. So I am in radians right now. I need to be in degrees. Let me try this again. What? Okay, well, pi over 4 is 45 degrees. So let's go, theta is 45 degrees. But notice that 45 degrees does not appear in the quadrant that we already said. We said quadrant 4. That's in quadrant 1. So remember, if you're in the top 2 quadrants, you leave it alone. If you're in the bottom 2 quadrants, you have to subtract by 360. So 360 minus 45 gives you 315. So that's the correct angle, but none of these angles are in degrees. They're all in radians. So at this step, you're going to have to convert to radians using the proportion 180 over pi is equal to 315 over x. So remember, you want to line up your degrees so they're both at the top and the radians are both at the bottom. At this point, you're going to cross multiply. So you have 180x equals 315 pi. Divide by 180 so that you can isolate x. You want x by itself. And when you put that in the calculator, you get 7 over 4. And then you just want to put the pi back in. You're not going to put the pi in the calculator because that has to be in your answer. And just like we said, C is the correct answer. Moving on to number 7. Julissa wants to find the measure of angle A in triangle ABC. She uses the law of cosines to work the problem as shown. In which step did Julissa make a mistake? So when you use the law of cosines, whatever angle you're solving for has to be the first letter in the formula. And remember that angles are across from sides. So if this is angle A, then this is little a, this is little c, and this is little b. So if she's looking for angle A, that means she has to start with A, and the formula, it's under your formula chart. If you look at your law of cosines, which is up here at the top, and you would follow the one where they start with A. So A squared equals B squared plus C squared minus 2BC cosine A. And then so you would do 11 squared, and then, well, let's just make sure she plugged everything in right. So the first thing she did was 11 squared, so that's A, that's good. B and C, that's 9 and 7 all the way through, so that's all good. 11 squared is 121. Let's check if 7 squared plus 9 squared is 130. Enter. Okay, so it is 130. And then negative 2 times 9 times 7 That is negative 126, which is what she had. So she simplified everything correctly. She set it up properly. The next step here would be to subtract 130 on both sides. So then these would cancel out, and 121 minus 130 is negative 9. And she put positive 9 on hers, so her mistake was made on step 3. Moving on to number 8. If cosine theta is 7 over 25 and tangent theta is less than 0, what is the value of cosecant theta? So they tell you that cosine is positive, tangent is negative because it's less than 0. You can use your all students take calculus coordinate plane to figure out what quadrant it has to be in. So since tangent is negative, it can neither be tangent or all because that's when tangent is positive. And then since we do have cosine is positive, the only place that happens is in quadrant 4. So we know that the final answer will be in quadrant 4. In quadrant 4, cosecant, since we're looking for cosecant, in quadrant 4, cosecant is negative because cosecant is the inverse of sine. So cosecant is only positive in quadrant 2 and it is negative in quadrant 4. So for that reason, our final answer will be negative. So even if you don't get further than this, you can eliminate C and D because we know it has to be negative. Okay? When they give you cosine, they're also telling you the adjacent leg and the hypotenuse. Because remember SOHCAHTOA, cosine is adjacent over hypotenuse. Okay? If you do the Pythagorean theorem to get the opposite leg, and you subtract 7 squared, then you end up with b equals 24, which would be the opposite leg. Now remember I said cosecant was the inverse of sine. Sine theta is opposite over hypotenuse, so the inverse of sine would have to be hypotenuse over opposite. We know already from reading quadrant 4 that this answer is going to be negative. The hypotenuse is 25, and the opposite leg that we just solved for was 24. So the correct answer is A as in apple. Okay, the next problem, which expression is equivalent to tangent squared theta equals secant squared theta plus cosecant squared theta? So this is a simplifying trig problem. To the side, I'm going to give you the methods that you can use. There are 4 methods. The first one is to rewrite in terms of sine and cosine. The second is to factor. The third method is to get a common denominator. And the fourth method is to split a fraction into 2 smaller fractions. Now you're not going to always use all 4 of them. It's just a matter of what the problem says. So I'll start with rewriting in terms of sine and cosine and see where that leads us. So tangent squared, you're going to look at your formula chart. So tangent squared. Tangent is sine over cosine. But because it's squared, that means that sine and cosine will also be squared. So you're not going to write sine over cosine, you're going to write sine squared over cosine squared. Secant is 1 over cosine. Again, it's squared, so it's going to be 1 over cosine. Oops. And then cosecant is 1 over sine squared. So PEMDAS says to do parentheses first. I have a set of parentheses with 2 fractions on the inside. If I need to add fractions, you need to have a common denominator. You cannot add or subtract fractions without a common denominator. One is cosine squared, one is sine squared. So how do you get a common denominator? You're going to multiply the opposite fraction by the opposite denominator. Right now, all I did was bring this down because we haven't used it. I'm going to rewrite what I have in parentheses, but I'm going to leave myself some space to multiply. Okay, so I'm going to multiply this fraction by this denominator, and then I'm going to multiply this fraction by that denominator on the top and on the bottom. Okay, now we got to simplify this. Now, if we're paying attention to PEMDAS, we're inside the parentheses. We have to multiply first before we think about adding them. You can't add yet. So how do you multiply fractions? You multiply straight across. So I'm going to bring down that front piece again because we haven't used it. Sine squared times 1 is sine squared. The denominator, if you can't add them or multiply them, you just write them next to each other. Plus cosine squared, sine squared, cosine squared. Now notice that they have the same denominator, so I'm going to rewrite everything with them sharing the same denominator of sine squared, cosine squared. Now that they're one fraction, we're going to add the numerators. So sine squared theta plus cosine squared theta. Now you might recognize this as a Pythagorean identity, sine squared plus cosine squared. Sine squared plus cosine squared equals 1. So I'm going to rewrite all of this. One over sine squared cosine squared. Okay, and again, it's 1 because of the trig identity. Okay, let me move this around. I'm not going to have enough space. Okay. Notice that you just have one fraction times another fraction. So all you got to do is multiply straight across the top times the bottom. So the top would just be sine squared. The bottom, you have cosine squared times another cosine squared. That's going to be a total of 4 cosines, and then you have a sine squared. This sine squared cancels out with that sine squared, so you're just left with 1 over cosine to the power of 4. And the reciprocal of 1 over cosine, if you find that on the formula chart, we had it earlier, 1 over cosine is secant. So remember, you got to match the power. So if this one was 4, then this one also has to be 4. So the final answer will be secant to the 4th power theta. So that answer choice is B as in boy. Let's say you forget how to do all of this. You don't remember the methods. You don't know how to use your trig identities, any of that. One way that you can try to salvage yourself is by putting an angle in theta. So let's say you just say theta equals 30 degrees. Where everywhere you see theta, you're going to plug it into the calculator using 30 degrees. And then you're going to see which decimal is exactly the same. So let's practice doing that. First, I need to figure out how to change this calculator to be in degrees. Okay, we're in degrees now. So there's going to be a lot of parentheses happening here. So you're going to open up a parentheses, and then you're going to do tangent of 30. You're going to close those parentheses, and then you're going to square it. So notice that on the problem, it's tangent squared. The angle, here you got to do tangent angle and then squared. Then I'm going to multiply that. I have another set of parentheses. I'm going to put another set of parentheses to put in there secant squared. So I'm going to do secant 30, close parentheses, squared. Plus, open up another set of parentheses, cosecant 30, close parentheses, squared. Now you're probably wondering, why are there so many parentheses? Because you want the whole tangent, the whole trig function to be squared. If you put the square on the inside, it's only going to square the angle. And you don't want 30 squared, you want tangent 30 squared. So pay attention to those parentheses because they're going to make a difference. Then you're going to press enter. Okay. Then you're going to go through the answer choices and see which one is right. So let's say I'm going to do A. So that's cosecant. And again, use the same fake angle that we've been using. We're going to close that, and then we're going to do to the power of 4 and press enter. That is not equivalent to 16 over 9, so A is not the right answer. Let's try B. So secant of 30, parentheses, parentheses, power of 4, press enter. That is equivalent to 16 over 9, and therefore now we can be sure that B is the correct answer. So again, if you just forget during the test how to do it by hand, that is a great method as well, as long as you're mindful of how you're putting those parentheses. Okay, moving on. What is the exact value of tangent negative 14 pi over 3? So similar to what we just did, you're just going to put this in the calculator. Notice though that the angle has a pi, meaning that the calculator has to be in radians. So before you get started, go ahead and change the calculator settings to radians. And then you're going to put tangent of negative 14 pi over 3. And you're going to get a decimal. Oh, well, my calculator is more advanced than your calculators. But in your calculators that you're going to have on the test, you're going to get a decimal. And then essentially you're going to type in the answer choices until you get a decimal that matches what you had started with. This calculator is more advanced, so it gave it to me in the square root form already. So yeah, C is the correct answer. But if you did it by hand, I think it was like 1 point equals 1.7 or something. So it wouldn't be D because it is defined. And then this one was like negative 1.7. And then I don't know what B is, but this one is exactly 1.7. So anyways, all right. Number 11, this is the last problem we're going to do in this video, and I'm going to do the second half in part 2. So tune back in for part 2 if you want the other 11 problems. From the top of a 550-foot cliff, a hiker looks down at a river below. Her angles of depression to the near and far banks of the river are 70 degrees and 50 degrees respectively, as shown in the picture. Based on this information, approximately how wide is the river? So there are two triangles happening here. So if you make a line from the mouth of the river, or whatever it's called, I don't know, like right here at the beginning of the river versus the end of the river, you create two separate triangles. So you have a small triangle that's right here, and then you have a bigger triangle, a wider triangle that's here. I personally get confused having all those triangles and all those lines in there. So what I'm going to do, I'm just going to draw them out separately so I can see them better. So there's a thinner one, and then there is a wider one. Okay, and they're both right angles. So notice that for the thin one, the angle starts all the way over here. So it's the bigger angle, which is 70 degrees. And then for the wider one, the angle starts right here at 50 degrees. For both of them, the height is 550, so that doesn't change. So how are you going to figure out the width of the river? Well, since you're solving for something that's horizontal, you're obviously going to want to find the horizontal distances. That hypotenuse is not going to give you any information. I'm labeling these X and Y because they are two different numbers, so I don't want to make them the same variable. So essentially what's going to happen, let me erase all of this because it's too much for me. Erase, okay. With the thin triangle, you're going to get this distance. With the wide triangle, you're going to get the entire distance. However, you only want this distance, okay? So if you subtract the little thin part from the big one, if you take this out, then notice that you're just left with the width of the river. So you need to find both horizontal distances and subtract them. And when you subtract them, you're left with the width of the river. Okay, so remember, across from the angle, you have the opposite leg, and next to the angle, you have the adjacent. And that's the same for the green one. So for both of them, we're going to be using tangent. Okay, so tangent of 70 is equal to 550 over x. Tangent of 50 is equal to 550 over x. At which point you would cross multiply on both of them. So you get x tangent 70 equals 550. X tan 50 equals 550. You multiply the denominator on both sides. To get x by itself, you're going to divide out the trig function with the angle. And then you're going to put that in the calculator. Okay, so let's go do that. So 550, and I am in radians, but I need to be in degrees because 50 and 70 are in degrees. So just always pay attention to that, of what mode you got to be in. Okay, so one of them was tangent 50. The other one was tangent 70. Oh man, how do I get the actual number? Let me see. Oh, I don't even know what that means. Okay. I don't know how to do it. Okay, but we're going to subtract. So I guess maybe if I subtract them, then I'll get a number. Sorry, you guys. I'm used to doing this on the actual inspires that we have in the classroom and not on here. So just be patient with me. What is that? Sorry. Oh wait, maybe I can just convert it to a decimal. How do I convert it to a decimal? Let's see. Oh no. Okay. Here. Oh no. Number. Convert to decimal. Okay. Perfect. And then the same for this one. Copy. Convert to decimal. Now for yours, it's going to be perfect. You're not going to have to do all this. But anyways, now you're going to subtract, obviously, the big one from the little one, and press enter. And when you subtract them, you get 261.3. And that answer is B as in boy. Okay. So like I said, if you want to see the remaining 11 problems, just go watch part 2 of the review. Bye, you guys.